The first thing that we need to do today is review degree and leading coefficient. This is something that we learned in section 4.1, which was back before winter break. So we need to think back a little bit. When you have a polynomial, your degree is your largest exponent. And your leading coefficient is the number in front of the term that has the largest exponent. The degree and the leading coefficient tell us a lot about the shape of the graph. Do you remember the whole odd degree, the ends point in opposite directions, even degree, the ends point in the same direction? So let's look at even degree versus odd degree. I'm going to write even degree versus odd degree. I'm going to make a little chart right here. And then we're going to look at positive leading coefficient. That looks like CC. That should be LC. And I just lost my little thingy. Sure. That works. That looks kind of dumb. Versus negative leading coefficient. Your leading coefficient controls the right side of your graph. So if your leading coefficient is positive, the right side points up. If your leading coefficient is negative, the right side of the graph points down. Your degree tells you if the other side does the same thing or the opposite thing. With even degree, the left side does the same thing. With odd degree, the left side does the opposite thing. So even, same, odd, opposite. And the leading coefficient tells you what the right side of the graph does. So basically, what we're going to do today is find the zeros. We're going to solve the polynomial to see where this thing's going to cross the x-axis. We're going to look at what the two ends of the graph are going to do. And then we'll kind of connect it in the middle and we'll have a sort of a sketch. We'll talk about turning and crossing points in just a second. The first thing that you want to do before you start factoring at all is look at the degree and the leading coefficient. So this one, the degree is the largest exponent. So the degree is 6. That means it's an even degree. So the ends are going to go in the same direction. The leading coefficient, is there a positive number or a negative number in front of that term? Positive. It's a positive 1. So the right end is going to point up. So we know the right end is going to point up and the left end is also going to point up. Now we're going to factor this. So now we're going to use what we learned on the last set of notes and factor this polynomial. We're going to do 0 equals. What do these three terms have in common? X to the 4th. X to the 6th, take out 4 of them, you're left with x squared. X to the 5th, take out 4 of them, you're left with x. And negative 6, x to the 4th, take out the x to the 4th, you have negative 6. Okay, we need to factor that trinomial. So we're looking for two numbers that multiply to give us negative 6 and add up to 1. I think that'd be 2 and 3. Negative 2 and positive 3. So we've got x minus 2, x plus 3. And we've got this x to the 4th in front. And we've got 0 equals. Okay, let's finish this by solving it. Let's do the parentheses first because those are the easy ones. If x minus 2 has to equal 0, what's the solution for this thing right here? Positive 2. If x plus 3 has to equal 0, our solution is negative 3. What about x to the fourth? 0. So our x intercepts, I'm going to write these in order, are negative 3, 0, and 2. Now, we're definitely going to be sketching this graph, like definitely sketching. So negative 3 is like here-ish. 0 is right here. And then 2 is like right there. It does not have to be super precise. You can definitely sketch it. They also want you to find the y-intercept. To find the y-intercept, just plug in 0. 0 to the 6th is 0. 0 to the 5th is 0. X to the 4th is 0. 0 times negative 6 is 0. Your y-intercept is the point 0, 0. So this point right here, it crosses the y-axis at 0. Okay. We know that the right side of the graph is going to point up. So somewhere here, this is gonna go up. The right side is also going to point up. We have to figure out how the heck to connect those points in the middle. Each of these x intercepts is a specific type of x intercept. There are turning points and crossing points. Turning points are points where when the graph gets to that x intercept, it turns and goes in the other direction. So a turning point looks like this. It's like it bounces on the x-axis. So either it comes up to the x-axis and then bounces back down, or it comes down to the x-axis and then bounces back up. So I like to call turning points bouncing points because it like bounces off of the x-axis. A crossing point is where it just goes right through. It just crosses the x-axis. If the exponent is even, it's going to be a turning point. So at 0, this is going to be a turning point. The 2 came from a factor that had an exponent of 1. The negative 3 came from a factor that had an exponent of 1. Those are both crossing points. So it's going to cross at negative 3. It's going to bounce at 0 and then cross at 2. Okay, now, what are you going to be expected to do on your assignment or on the test? I will give you a series of graphs, and I will give you the formula, the function. So, which graph matches this function? And sometimes, if you just do this part and figure out the degree and the leading coefficient, you may be able to have enough information to say, yeah, this one is going to be the right graph. But you may have to then factor it to find the zeros and then pick out which of those graphs has the correct degree and leading coefficient and has the correct zeros. Okay, let's try this whole thing again. First of all, I know it's written weird, but we want to start here with the degree and the leading coefficient. What is the degree of this particular polynomial? 4, that's even. So what does that mean about the ends? Same. The leading coefficient, -4, that's negative. So the right end is going to point down. The right end is going to point down. The left end is going to do the same thing. Okay, now we find the x-intercepts. Make this 0 equals. Anyone else see a problem with factoring this one? Do you see the negative in front? We don't like factoring when there's a negative in front. So whatever these 3 terms have in common, we're going to pull a negative out. Can we divide all those by 4? I think so. And x squared That will leave us with positive x squared. 8 divided by negative 4 is negative 2, and there's an x left there. 60 divided by negative 4 is negative 15, and we're taking the x squared out. Okay, take a moment, pause the video, finish factoring this. Okay, so we factored this, and sorry, my phone decided it thought I said something to it. Right here, x plus 3, we have a solution of negative 3. So one of our x-intercepts is negative 3. X minus 5 gives us an x-intercept of positive 5. What does negative 4x squared give us an x-intercept of? That negative 4 makes it look confusing, but it would still just be 0. Anytime you have a monomial term in front, one of your x-intercepts is 0. So I'm going to put these in order, negative 3, 0, and 5. Okay. Honestly, I think the hardest part is figuring out the turning point and the crossing point. You're looking at where that x-intercept came from. So this x-intercept came from this factor. What exponent does that factor have on it? It doesn't have 1. That means it has a 1. That is a crossing point. 0 came from this factor. It has an exponent of 2. That's an even number, so that makes it a turning point. 5 came from this factor, which has an exponent of 1, so that is going to be a crossing point. Okay, let's take all this information to the graph. There's negative 3. 1, 2, 3, 4, 5. There's 5 and 0. Negative 3 is a crossing point, so I'm just going to put a slash through it. 5 is a crossing point. I'll put a slash through that one. Oops. Okay. The left end needs to point down. The right end needs to point down. This one has to be a turning point, so it looks like it's going to bounce on that point. It doesn't have to be super precise. Basically, this is going to tell you it's going to be like an M shape, a W shape upside down. All right, I want you to try the next example almost entirely on your own. You might notice that we skipped this y-intercept part because our y-intercept in this one was also 0. In this next one, you do have a y-intercept. If you put 0 into this entire function, the first 3 terms would be knocked out. You would still have 9. This graph is going to cross the y-axis at 9. That's another point that we can put on there to help us. And that's another point that you can use to say, okay, which of these graphs crosses the y-axis at 9? That one, that's probably my answer. All right, so I want you to start by finding the degree and the leading coefficient, and then factor. Be brave. Give it a try. Pause the video. Give it a try. So first you want to factor out a negative 1, and then you are going to do factor by grouping. So take this 4 terms right here, split it after the second term, factor by grouping. Honestly, this negative 1 right here, it's not going to affect anything. The only thing the negative 1 is really doing is making that right end of the graph go down instead of going up. So you can basically ignore that negative 1 because there's no x out there. It's not going to affect anything. Okay, so our solutions are negative 3, positive 3, and negative 1. Notice there's no exponents left on these factors, so these are all going to be, they're all going to be crossing points. This negative 1, there's no x there, so that's not really associated with an x-intercept at all. So our x-intercepts are negative 3, negative 1, and 3. Our y-intercept is 9. See if you can get that on the graph. Honestly, if you have information about the degree, the leading coefficient, so what the right side does, what the left